corrections, and tomorrow is the last day to retake Chapter 2, Test Part 2. So make sure you're making time to do that today or tomorrow if you want to do that. Today we're going to talk about graphs. We're going to talk about graphing with our scientific calculator to help us, like ln and log 10. You can just use your calculator. But if I asked you to graph something else, like log base 2 or log base 5, we want to talk about how can we do that without a calculator. And again, because we're going to have a calculator part of our test and a no calculator part of our test. So remember that logarithms and exponential functions are inverses. So they're symmetric when you graph them. I don't know if you remember about inverse functions. Have we talked about inverse functions in here? Yes, ma'am. That they're symmetric. So I wanted to graph 2 to the x and then log base 2 of x so we could talk about their similarities. If you know how to graph 2 to the x, you can always use that to help you graph logarithms. So this is what we did last week, right? Exponential equations. I'm just going to pick a few points. My favorite points to pick are -1, 0, and 1, because it gives me that negative exponent, which gives me a fraction. It gives me the 0, the y-intercept, and it gives me the positive direction. Also, 2 to the x is my favorite one to graph because 2 doesn't get big that quickly, right? 2 squared is 4, 2 to the third is 8. So, I don't spend that much time doing this, but 2 to the -1, right, that's just 1/2. 2 to the 0 is 1, and 2 to the first is 2. And that's just our standard exponential growth model. As x gets bigger, y is going to get bigger. As x gets smaller, we're just going to keep getting those fractions, like 1/2, 1/4, 1/8, 1/16. So, I'm going to pick a few more points over here that aren't in my graph. But like if I plugged 2 in there, 2 squared is 4, 2 to the third is 8, right? So I get a lot of points. And remember that we have that horizontal asymptote, that we never get 0, we never get a negative number. That's why when we take the log of a negative number, it's undefined. You can't get a negative number out of an exponential graph. Right? So I'm going to write f of x here. One thing, if you can remember about inverses, definition of inverse is just that the x and y switch places. So you should be able to just switch all your ordered pairs, but you're not going to want to have to graph both every time. So think about what x represents in this problem, right? If you were going to rewrite this, this would say 2 to the y equals x, right? So if you're going to pick x values, you have to pick powers of 2. Right? So, power of 2. 2 is a great power of 2. What exponent would give me a 2 here for x? What exponent would go here? 1. And you can check. If 1, 2 is on this graph, 2, 1 has to be on the inverse. That's the definition. What are my other go-to numbers I pick for logarithms? What would give me 1? 2 to the what equals 1, right? That's going to give me 0. So instead of having a y-intercept of 1, I get an x-intercept of 1. And then my other go-to one is 1 over the base, or in this case, 1/2. What exponent would give me 1/2? -1. And if you notice, I just switched every point over there. No matter the logarithm I give you, if you pick 1, the base, and 1 over the base, you'll always get nice numbers. And we'll do some harder ones in a minute. But I just wanted to show you this reflection property here. 2, 1, 1/2, -1. Did I do that right? That's not right. 1/2, -1. Sorry. And I don't. We could pick the other points, right? To get 4, the exponent would have to be 2. If I plugged in 8 for x, the exponent would be 3. Right? We're just switching all those points. this side is going to go up really slow. Think about 2 to the 6th is 64. So if you went all the way out to 64 on the x-axis, you'd only be up to 6 on the y-axis. It goes up very slowly. What's going to happen back here as I plug in more and more powers of x, like 1/64th, 1/28th, I don't know what's going to happen there. Yeah, over here we have a horizontal asymptote, so on a logarithmic function, you're always going to have a vertical asymptote. And again, transformations can change this, but if there's no transformations, the y-axis will be the vertical asymptote, because you can't take the log of 0, you can't take the log of a negative number. So if you remember anything about inverses, right, they're symmetric about that line y equals x, which means that you should be able to take that flat graph I graphed and flip it over, and it makes the logarithmic graph. So I always say, if you get stuck, if you forget, logarithms kind of stress people out sometimes. 2 to the x, most people know that's exponential growth. If you know that, and you know there's a horizontal asymptote, then if you remember that they're inverses, then flipping it over, knowing now there's a vertical asymptote, should hopefully maybe be helpful. Okay. All right, so let's graph ln. Your book focuses a lot more on ln than log other bases. I kind of like to do both. I don't like ln as much because you get decimals, right? It's harder to do without a calculator. But it's the same idea. It's log base e. We can pick numbers. There's a lot of applications, and so that's why we should probably do it. So I'm going to say x. We say y here. I'm going to say g of x. If you know the shape and you know the asymptotes, you can really pick whatever you want, because ln you can use your calculator. What can't I pick here for x values? Can't pick negatives. Can't pick 0, right? Here's what I pick every time I'm out of the problem. What's the base of ln? E, every time. I pick the base. I pick 1 over the base, which is kind of weird in this one because it's 1 over e. That's going to be not a great decimal. But even with this, I can pick 1 over e, and I pick 1. Even with ln, when I plug 1 in there, what is the ln of 1? Log e of 1, or e to the what power equals 1? 0. Here's what's great about ln. Do it on your calculator if you don't know. It'll tell you it's 0. Now, e is that decimal, right? It's like 2.71. So even if you pick e, you're going to graph a decimal. But what is the ln of e? 1. Also, because you're on your calculator. And then 1 over e. I just want to pick that one just because I do that even when it's not e. As a decimal, 1 over e is like 0.4. But why did I do that? What do I get when I plug ln of 1 over e? What does that simplify to? Can I write 1 over e as an exponent? Same as ln of e to the negative 1. Let's just say 1. Right? If you type in your calculator, it should give you the right answer. If you don't want to do that, pick whatever you want, right? Pick 7. And when you type in on your calculator ln of 7, you're going to get 1.94. Right? If you want to just pick whatever numbers you want, pick whatever numbers you want. But this shape should be the same that we graphed as log base 2, except for now it's base e. All right? So know with ln, know with log 10, you can pick whatever whatever you want, as long as you're not getting an undefined answer. If I graph this 1, 0, at E, which is like 2.71, it's going to go up to 1. At 0.4, I'm going to get that -1, right? I get that same shape, and that's what I'm really looking for on graphs, just like with exponential graphs. I'm looking that you know the asymptote, so I'm looking that you know there's a vertical asymptote, that you're never going to get to 0. And I'm looking that you know that this side goes up pretty slow. You notice I picked 7, and at 7, it's not even up to 2 yet, which means I'm not going to be super picky on this, but I don't want to see this. Right? It does not go up that fast. It goes up very slowly. And if you think back to when we did chapter 1, we talked about those 10 basic graphs. We talked about that ln of x goes up so slowly that if you went a mile on the x-axis, that's only like 1 foot on the y-axis. Like it goes, like it rises very slowly. But I really want you to know those shapes as we do that. And so notice on this one it says find the domain, find the x-intercept, and the vertical asymptote, just because you want to kind of know those basic things as you're doing this. What's the domain of this? What kind of values am I allowed to plug in here for x? 0 to infinity, not including 0. Look at your graph. It never gets to 0. There are no negative numbers. You can't take the ln of 0. You can't take the ln of a negative number because there's no exponent that will give you those negative values or 0, right? What's the x-intercept of this graph? Yeah, and if you think about with exponential functions, we always talked about the y-intercept was 1, right? We've switched them. So now our x-intercept is 1. I'm going to write it as a 0.10. And again, that's because log of any number, any base of 1 gives you 0. And the vertical asymptote, remember, asymptotes are equations. The vertical asymptote is what we're never getting to, which in this case is going to be x equals 0. And the only way that's going to change is if we translate that left or right, right? So if we slide it over by adding or subtracting a number, that's going to change our vertical asymptote. Questions about that? Okay, so let's look at the next one kind of both with and without a calculator. I'm going to do it first without a calculator, and then we'll talk about again how our calculator can help us do this, and then we're just going to kind of talk about our basic stuff we should know. Okay. So what if I give you this with transformations? If you know your rules of transformations, it should help you kind of recognize what your graph looks like. What does a negative out in front of your graph mean? That's happened to our graph. It's flipped over the x-axis. So normally it's like the asymptote's down like this, right? We're gonna flip it over, so that's gonna change things. What does a -3 inside the function mean we're gonna do? Move it right 3, which means the asymptote has changed. So now it's moved over 3 units. So again, I'm really looking for the asymptote here when you do this. This is log base 10, right? If there's nothing there, you know it's log base 10, which means, just like ln, if you want to pick numbers on your calculator and you want to get decimals, it works every time because you can just do it on your calculator. But even if you're using your calculator, you need to be aware of like the smallest number you can pick or what the domain of this would be. What's the number I'm not allowed to plug in here? Like where would my domain start on this? Do you know? 3, because on the last one it was 0. I can't plug 3 in there because that's going to make that go to 0. So I know right away my domain is going to be 3 to infinity. If you didn't know that, pick some numbers on your calculator until you can't plug in the numbers anymore. So that tells me that I'm going to have my vertical asymptote. Okay, sorry. -3. This way, right? So what if we pick 4? Without the calculator, does that work? If I plug 4 in there, I have negative log calculator? Zero. Standard of what equals 1 is 0. Oh, well, it does, but you can't make it 0, so that's why it doesn't matter. Right? Because on this one you would get -0, but you can't have a -0. So we can pick any number we want here, but for a minute, before we use our calculator, can you think of a number that we could pick for x so that when we plugged it in, that we could do it without a calculator? Meaning, this has to end up being a power of your base. So what number could we actually work out? What number would we want to be there? How could you do this without a calculator? Yes, find numbers that give you easy answers, meaning numbers that give you powers of 10, right? What's the power of 10 that we know? 1,000. I don't want to pick 1,000. What's this? 10 to the second is 100, right? So we could do that. I don't really want to graph that, but we could. What number would you have to pick for x so that when you plugged it in, it would look like this, right? Because I need it to be log 10 of 100. So what number would I pick for x? You have to pick 103 so that when you subtract 3 from that, it gives you a power. Does that make sense what I'm saying?
So we're gonna have to like sort of graph like 5.
Well, we don't really need to graph 103, but like we could pick a better number. See what I'm saying? Like I don't think we really have to graph 103. But if we did graph 103, what would be the y value that went with that? What would this be? What is log 10 of 100? 2. 10 to what power equals 100? This is what we did on the homework yesterday. This is what you have to be able to do without a calculator when we have a test, is be able to work these logs out without a calculator. 10 to what power equals 100? The answer is 2. If there's a negative in front, which means it's -2. I'm not actually going to graph that because I'm not going to make my graph go to 100. What's a smaller power of 10 besides 100? Right, that was 10 to the second. Another power of 10. 10. Is 10 the power of 10? Just 10 to the first. So this part helps me sometimes. I want this to say log 10 of 10. So what number do I pick for x so that that will give me 10? 13. And then what do I get here when I take negative log 10 of 10? -1, because 10 to what power equals 10 is 1, but it's a negative in front of it. Right? I like to pick the base, so I like to pick so I get 10. I like to pick so I get 0, and then I always like to pick so I get a fraction, but you don't have to do that if you don't want. But the other one that I would pick would be this, because I like to say, right, log 10 of 1/10 is just a negative exponent. But then you have to think about fractions. What number would I pick for x so that when I take x minus 3 that I get 1/10 as my answer? I want x minus 3, right, to equal 1/10. So what does x have to be? 3 and 1/10, right? And when you plug that in, this is -1, but negative of a -1 gives you a +1. Here's what's great about log base 10. You could have done this all in your calculator, right? You could have picked whatever you want for x as long as it's in the domain, and got the decimals to go with it. But I'm telling you on your test, maybe on a quiz we're going to have sometime soon, I'm going to give you one like this without a calculator, whether it's log base 10, maybe it'd be log base 7, maybe log base 5. It's going to be something that I want you to be able to know that that you can think through picking the answers to know what it's supposed to look like. All right? On your homework, it's a lot of calculator stuff, right? Like just to show you. What if you didn't want to think like this? And you'd be like, I just want to pick 5 for x. Pick 5 for x, and you get negative log of 5 minus 3, which is 2. It does not work out nice, but your calculator, you can just type it in. Negative log of 2 is negative 0.3. Right? So if you want to pick whatever you want and get ugly decimals, you can. But at some point in your future, you're going to have to do one of these without a calculator for me. So that's why I wanted to make sure I go through it. So then sometimes it's kind of tricky with the negative out front. But let's think about what this would look like if we graph this. 4, 0. Right? So we've just moved over 3 units. I'm not going to graph 103. But at 103, it would be at negative 2. So again, kind of thinking about how slowly that's going. At 13, I am going to make that go off my graph a little bit. 13, it would be at negative 1. And at 3 and 1/10, right? So going the other way here, it would be up there at 1. So remember, the negative out front tells us that it flipped. Normally, it's down like this and going up. And now it's flipped over. So this side's going to go up towards my asymptote. And this side's just going to very slowly go down, decrease, right? At 103, it would reach negative 2. So just make sure you don't make that like drop drastically when you graph that. If you remember your transformations, they can really help you get an idea if your graph looks right, just based on that. Questions about this? Again, your homework today is lots of ln and log base 10. So you can use your calculator. Worksheet on Friday is going to have some of both. Like definitely some where you have to pick the points without a calculator to help you. So that's why I'm going to talk about that. We did a paper just like this over exponential functions, talking about domain and range, increasing, decreasing. Remember that this only applies if there's no transformation, but your book always does this with each type of graph. Remember that log a of x and ln of x, they're both logarithms. Ln is just that base e, so it's always base e. Log a can be any base. If you think about the domain and range of exponential functions, the domain and range of this should just be switched. Right? What is the domain of log a of x every time if there's no transformation? What numbers aren't you allowed to plug in? So think about our graph. Here's our graph. Yeah. Like that's just a basic graph if I don't even talk about what a is. That the domain is going to be not including 0 to infinity. What's the range of every logarithmic graph? Are the y values restricted on this graph? The y values are not restricted. This goes down forever. This goes up very slowly, but it does go up, which means the range is all real numbers. If you go back and look at our stuff from 3.1, exponential functions, the domain and range have switched. The domain of exponential functions is all real numbers. The range is 0 to infinity. The x-intercept, I kind of filled the rest of this out for you. The x-intercept is always going to be 1 unless there's a transformation. It should be increasing unless it's flipped, then it could be decreasing, but they'll always be continuous, and there'll always be a vertical asymptote on that graph. So when I'm checking your graphs, I'm really checking that x-intercept is right and that your asymptote is right. The basic shape is right on those. Questions about that? You will definitely have to graph these on both parts of the test, with and without a calculator. So when we do that worksheet this week, that'll be a good idea of the without a calculator. So day 2, 37 through 40, I believe, are matching 4 graphs with equations. So use the transformations to help you if it's moved over or up or down. And then 43, 45, and 49, I want you to graph those. Use a calculator to help you in terms of picking your points if you want. They're ln's and logs. And then I have some story problems of why are logarithms so important, talking about sound absorption. I will tell you 59 says use the table 317. That means you're going to have to turn your page back a couple and find a table in your book that gives you an equation for that problem to find the sound intensity. So the rest of those are just kind of some story problems to talk about why we use these. And then tomorrow we're going to get into the properties of logarithms, hopefully kind of have you discover those properties